Welcome to Guided Practice 18. This is section 4.8 on linear approximation. We've got a couple of quick problems here. We're going to, for two different values here, for number 1 and 2, we're going to estimate the given value. Okay, when you're trying to estimate a given value, you need to have a C value, right? So we're going to need, in order to find linear approximation, I'm going to need a C and A, an F of A, and an F prime of A. Those are the four things that goes into my formula. Let's start with C. The C value is the number that you're approximating for and the number that's given. So that's going to be your 18. If you take the 18 out and replace it with an x, that gives you your f of x. So f of x here is going to be the square root of x, or x to the 1/2. The A value is a number that's close to C, but works well in my function. So I need to know my function here is the square root of x, so I need a perfect square that's close to 18. So I'm going to go with 16. Okay. Then f of a means we plug that in. So what is f? If f of x is the square root of x, and I plug in 16, that's the square root of 16, which is 4. And then f prime of a, I've got to work for. So first we take our derivative. So that's 1/2 x to the minus 1/2, or 1 over 2 square root of x. And again, I convert back to square roots because we're plugging things in. Okay, normally I wouldn't, but because we're plugging numbers in, to me, the square root of x makes a lot more sense when I'm plugging things in than x to the 1/2. And then we're going to plug in our 16. And when you do that, you get 1 over 2 root 16, which is 1/8. So my f of a is 1 over 8. And once you have those four values, then you're plugging into L of C. And L of C is f of prime at a times c minus a plus f at a. And so my derivative is 1/8. My c value is 18 minus my a is 16. And my f of a is 4. So this is going to give me 1/8 times 2 plus 4. And that's 1/4 plus 4. So my approximation is 4.25, or 4 1/4. Similar procedure for number 2. In number 2, we're going to have a C, an A, an F of A, and an F prime of A. Those are the four values that I need. The C value I can pick out. That's the one that I'm doing something to in the problem. So that's the 2.001. A is a number that's close to that. I'm going with 2. When I take the 2.001 out, that gives me a function f of x is equal to x to the 5th. And when you plug your function there, we're taking 2 to the 5th, and that is 32. Lastly, we need f prime of a. So f prime of x is 5 times x to the 4th. And so my f prime of a means that I'm plugging in the 2, the a value. So this is 5 times 2 to the 4th. And that's 5 times 16, which is 80, if I'm doing my math right. 5 times 16, 5 times 6 is 30, 5 times 10 is 50, so 50 and 30 is 80. So I have 80 here. Okay, and then I'm plugging into my formula. L of C is f prime of a times c minus a plus f of a. And so my L of 2.001 here is going to be the derivative, which is 80, times c minus a is 2.001 minus 2, plus my f of a, which is 32. And so you're taking 80 times 0.001 when you subtract, plus 32. Let's see, when you multiply that by 80, you get 0.08 plus 32. And so you have 32.08 is your approximation. And those will go similar every single time. Other types of things that I can ask you is to find the linear approximation of the function at the specified value. And in this case, I don't have a C, and my answer is going to be a function, L of x, in terms of x. So that means that I need all the other three, though. I need an A, an F of A, and an F prime of A. My function is given as sine of x, and my x equals 0. They're telling you what the a should be. So a is going to be 0. When you plug in a to your function, you're finding the sine of 0, which happens to be 0. And then the derivative of sine is cosine. And so for f prime of a, you're plugging in the cosine of 0. That turns out to be 1. And our L of x is f prime of a, x minus a, plus f at a. And so that means our L of x is going to be, our f prime of a is 1 times x minus 0 plus 0. And when you simplify that, that's just L of x is equal to x. And that's pretty typical for sines and cosines because you end up near 0 anyway, because you end up with a bunch of zeros that you're going to plug in. Depending on the function, your zeros are in one place or the other. And for e to the x, we have something similar. So you have an a, or you need an a, an f of a, and an f prime of a. You're given the function e to the x, and an x equals 0. So my a value is going to be at 0. F of a, when you plug that in, e to the 0 is 1. When I take the derivative, I get e to the x. And so when I plug 0 into that for my derivative at a, I get 1 e to the 0, which is 1 again. And so my L of x here, f prime of a, x minus a, plus f at a. So my L of x is 1 times x minus 0 plus 1. And in this case, that gives me my L of x is just x plus 1.